So here we have a standard correlation hypothesis test question. We've been given some data and we've been asked to test at the 5% level of significance whether there is positive correlation between the data above. Now, just pulling out the most important aspects of the question, they are the 5% level of significance and the fact we're looking for positive correlation. That will set us up to successfully respond to this question. Every hypothesis test question starts off with the actual hypotheses. H0, rho equals 0. H0 says that there is no correlation. By default, we assume no correlation. H1, that's going to come from the question. And the question says there's positive correlation. So H1 will be that rho is greater than 0. Lots of students lose marks right here. They don't use 0, they use 1. They don't use rho, they use r, or mu, or x bar. You have to get this in the right form. We're testing for rho, and we're testing it against 0. This is the first 1 or 2 marks of the question. Absolutely no need to lose marks here. The next things that we should be writing down are the significance level, and the notation for significance level is alpha. So alpha equals 0.05. We also need a value for n. Each of these columns is a set of data. We may well be taking people's biology score and their chemistry score. So for each person, they've given us 2 pieces of data. Each pair contributes 1 to the n value. So looking at this data, this may well have come from 7 people. Mistake to be made here is some people say 14 pieces of data. There's 7 pieces of bivariate data. So n equals 7. Together, the significance level and the n value help us to find the critical value. The critical value is going to come from the tables. So you need your reference tables with you, and we should be looking in the column that has alpha equals 0.05, and then for the row, n equals 7. And that value, in this case, is 0.6694. Okay, this is an important value. This helps us to decide, this is our decision maker. This lets us know if we have enough evidence to reject H0 or not. So, on a diagram, and the diagram would always help. The diagram is useful in every single hypothesis test that you do. We've set our boundary, 0.6694. If our calculated value is inside this shaded region, we have evidence to reject H0. The shaded region is always where we're rejecting. The shaded region is always where we reject H0. So draw a diagram. I said this is for a correlation hypothesis test, binomial hypothesis test, normal distribution hypothesis test. And if you do further maths, there's another 6 or 7 hypothesis tests. Each and every one of them should have a shaded region. And if you're in that shaded region, you're rejecting the null hypothesis. Okay, the diagram's set up. We now need to calculate our R value. To calculate R, we're going to put these 2 lists, X and Y, into our calculator, and we're going to use the correlation summary screen under the calculation menu. When you put all of that through, you get R equals 0.6488. That is outside of the shaded region. We're not going to reject H0. This is not a significant result. There is not enough evidence to reject H0. We now need to formalize this, and we're going to finish off with 3 more lines. Firstly, we're going to compare these 2 values. We just need to show that our calculated value was less than our critical value. Because of this, we have a significant result. There is not enough evidence to reject H0. So that's our mathematical conclusion, which is just about H0. And then our contextual conclusion, which is about whatever the question was about. And here we can just simply say there's not enough evidence that there is positive correlation between the data, or in this case, between X and Y.